Today I'm gonna be explaining chapter 13, question number 1, part A. In question number 1, part A, they're talking about the distance from one comet to the center of the sun at perihelion and at aphelion. So let's go ahead and write these two down. Okay. So distance of perihelion. This is gonna be the maximum radius of the perihelion. This is gonna be the minimum. So let's put the values that they gave us. The first one's gonna be 3 times 10 meters, and then 6 times 10 to the 9. Okay. So the formula that we're gonna use for this is gonna be the following. We're gonna use the formula that's gonna be radius maximum, max time plus radius minimum. This is gonna be all over 2. So let's go ahead and plug that in. So we have this right here. Let me put out the scientific number over 2. And then that times 10.9, which is this one over here. I put it right here, sorry. 10.9. Then when we go ahead and do this in our calculator, we get that the semi-major axis, it's gonna be 1.5 times 10 to the 12 meters. Okay, so now let's go ahead and go with part B. Let's see what part B says. Part B, for this comet's orbit, find the eccentricity. So let's go ahead and put the formula for eccentricity, which is gonna be the following formula. It equals 1 minus over the semi-major axis. So let's go ahead and plug that into this formula. So we're gonna have 1 minus 6.0 times 10 to the 9, and then 3 times 10 to the second. When we put that in our calculator, we're gonna get that eccentricity. It's gonna be 0.99A. And then this is gonna be part B. Now let's go ahead and do part C in this corner. Let's see what they're asking us for part C. For this comet's orbit, find the period. So let's go ahead and put the formula for the period. So formula, this, it's gonna be period squared area times over 2 times mass, and then gravity. So let's go ahead and plug that in. Let's see what we have. We have period times 3, and then this is gonna be cubic. Then we have 2 times 2, 10 to 30 times 6.76, 10, 11. And then when we put that in our calculator, we're gonna get 31.8. This is gonna be the period. Alright, now let me go ahead and go with part D. Now for part D, but they're asking us that the orbit of a certain asteroid around the sun has a period 7.85 and an eccentricity of 0.250. Find the semi-major axis. Let's see. So they gave us the period, and we also have the eccentricity. So let's see, we can use the same formula that we were using before. So let me go ahead and put this right here. Period over period 2. So it's going to be changed a little bit because what we want to find is the semi-major axis in this case. So let's solve for that. This is gonna be 1.699, then 33.6, and then now let's solve that. 1.193 to 10 meters, and then we're gonna divide this by 2, and this is gonna give us 5.91 times 10 meters. So when we go and see, this is going to be the semi-major axis for this question. Now let's go with part E. Let me go ahead and do it right here. Part E. Let's see. Find the distance from the sun to the asteroid at perihelion and aphelion. Okay. So now we are finding the distances from the sun. So we have the eccentricity, which they gave us to us in the last question. They also have, now we have the semi-major axis, which is the one that we just found. And then we also have the period, which was 7.85. Wow. Okay. So now let's find the formula. The formula that we're gonna use is gonna be the following. It's gonna be this 1 minus eccentricity, and then we're gonna solve to find the distance from the sun to the asteroid. So let's go ahead and find RA and RP. This is gonna be the formula for RP, which is gonna be the radius of the perihelion, and then the radius of the aphelion, which is going to be eccentricity. So let's go ahead and start with the first one, which is perihelion, and then we have the semi-major axis, 11, and then 1 minus eccentricity. When we go ahead and do that, we get that this is going to be 4.43 times 10 to 11 meters. And then now let's do this one, which is going to be the same, but we are going to use a negative value over here. So it's going to be 1 plus, we are going to do the sum in this case. And then we get that it's going to be 7.39 and then 10 to the 11. So the radius to the perihelion until the aphelion, it's gonna be 4.43 times 10 to 11, 7.39 to 11, and this is gonna be your answer. Now let's go ahead, continue with part F. Okay, part F. Let's see what the question says. Part F. The minor planet makes exactly 2 orbits of the sun during that time. That Neptune makes 3. The eccentricity of the orbit is 0.25, and the orbit radius of Neptune is 4.5 times 10 to the 12. Find the semi-major axis of this minor planet. So now we have the eccentricity of it, we have the radius. Let me just put it down. Radius of Neptune, it's going to be 1.5 times to the 15. Then we have the eccentricity as well, which is going to be 0.25. And now let's go ahead and try to find a formula to find the semi-major axis for this. So let's go ahead and try to find this. So I think we can use the following formula, which is gonna be period equals to, just gonna be radius over 3 over gravity, the mass, and then this times over 2. The period Neptune is gonna be 1/3. So let's go ahead and try to solve for this so we can find it. Okay, then we have this. This is gonna be algebra right now. Let's try to cancel that out so we can put it in one side. And then here, and then now, the radius that we had, let's try to get that out. And let's use this formula to try to find it, which is gonna be the semi-major axis of this minor planet is gonna be 5.89 times 10 to 12. This one was a little bit complicated for me because when they have a lot of algebra, it just takes longer for me to figure it out. Okay, now let's go ahead and go with part G. Now they want us to find the distance between the sun and the minor planet at the perihelion. So we have the eccentricity. We also have the semi-major axis, which is the one that we just found. So let's put those two down. And here, the one that we just found in the previous question. And let me write the formula. The formula, we're gonna use the formula we used for the question before this one, which was radius of the perihelion equals semi-major axis minus 1 and then minus the eccentricity. So let me go ahead and solve for that. Okay, so we know that the semi-major axis is 5.9 because we rounded 10 to the 12 times 1 minus 0.5, which is the eccentricity. Then let's put it down over here. We're gonna get 9 to 12 times 0.75. And when we put this in our calculator, we're gonna get that the multiplication is gonna be 4.42 times 10 to the 12. Okay, and then that's gonna be the distance between the sun and the minor planet. Now let's go ahead and do part H. Part H, right? Part H. Let's see what it says. Part H says the following. In 2017, astronauts discovered a planet. The orbit of the planet has a semi-major axis of 7.41, eccentricity of 0.173, and a period of 4.39 days. Find the distance between HATS 43 and the planet. Okay, so in this case, they basically gave us everything. So we have eccentricity, we have period, and the periods we're gonna have to convert those. So let me go ahead, and we also have the semi-major axis. So the eccentricity was 0.173. 0.3. The semi-major axis is 0.41 times 9. And the periods, we're going to put them in days for now. Okay. So now, let's put the following formula, which is going to be this one, which is going to be that the distance, it's going to be the semi-major axis 1 minus the eccentricity, which is the one that we already used. And then let me go ahead and put that here. 7.41, which is our semi-major axis. And then inside this, 1 minus 0.173. And then this is really simple. We put that in our calculator. And we get that the distance is going to be 6.13 times 10 to the 9 meters. And that's going to be our radius, or our distance of the planet. Now I'll find the mass of this. Now they're asking us to find the mass. So let's go ahead and do par I. So we have the same values as before, but in this case, let me put them down again just so we can have them. And now we're actually going to need to convert the days into periods. So let me go ahead and do the conversion right here, which is going to be 4.39 times 24 hours times 3.6. This is going to give us that this in seconds is going to be 3.794 seconds. And let's go ahead and put the formula to get the mass in this case. We're going to use this formula, and then we're going to solve for the mass, because there is no formula to get the mass, but there is a formula we can just solve it and find the mass. So let me go ahead and do that. We're going to solve for the mass, and then this all stays the same except for the bottom. It's going to be times the period. So now what do? We just put in our numbers, and then to the formula. So we have the first one is going to be 4 times pi, so 3.4 times pi again times the semi-major axis to the third. So let me go ahead and do that. To the third, and at the bottom we're gonna have the gravity of Earth times or period, and then we have it in seconds already, so we can go ahead and use this square. When we go ahead and put that in our calculator, all of it, we're gonna get 1.67 times to the 10, 30, and then this is gonna be in kilograms. And that's it.